Among the most remarkable features of centenarians is not simply their long lifespan, but the preservation of cognitive function into extreme old age. While the prevalence of dementia increases sharply with age in the general population, a significant proportion of centenarians exhibit what researchers call cognitive resilience, a maintained ability to think, remember, and function independently well beyond 100 years of age. This phenomenon has sparked growing interest in understanding the biological and environmental factors that protect the brain from age-related decline. As evidence accumulates, it is becoming clear that neuroprotection in the oldest old is multifactorial, involving a dynamic interplay between neurotrophic factors, inflammation control, vascular integrity, and potentially advantageous genetic and lifestyle profiles. One of the key players in maintaining brain health is brain-derived neurotrophic factor, BDNF, a protein that supports the survival, growth, and differentiation of neurons. BDNF plays a vital role in synaptic plasticity, the mechanism that underlies learning and memory. In aging populations, reduced BDNF expression has been linked to cognitive impairment and the progression of neurodegenerative disorders such as Alzheimer's disease. In contrast, centenarians often demonstrate preserved or even elevated levels of BDNF compared to age-matched individuals with cognitive impairment. This preservation may reflect a lifelong pattern of physical activity, social engagement, and metabolic health, all of which have been shown to stimulate BDNF production. In animal models and human studies, interventions such as aerobic exercise and intermittent fasting increase BDNF levels, suggesting modifiable pathways to enhance neuroprotection. Inflammation is another critical factor in brain aging. The concept of inflammaging, a chronic, low-grade inflammatory state that emerges with age, has been strongly associated with neurodegeneration. Pro-inflammatory cytokines such as IL-6 and TNF-A have been implicated in synaptic loss, microglial overactivation, and blood-brain barrier disruption. However, cognitively intact centenarians tend to exhibit lower levels of systemic and neuroinflammatory markers, suggesting that their immune systems remain more tightly regulated. Elevated levels of anti-inflammatory mediators, including IL-10 and TGF-SS, are often found in long-lived individuals, supporting the idea that a balanced immune profile may prevent or delay the onset of cognitive decline. Genetic factors, such as variations in the IL-10 promoter region or in immune regulatory genes like FOXO3A, may contribute to this anti-inflammatory bias. Closely tied to inflammation is vascular health, which plays a foundational role in cognitive function. Cerebral small vessel disease, impaired perfusion, and blood-brain barrier breakdown are all recognized contributors to age-related cognitive decline. In long-lived populations, including centenarians, vascular profiles are often surprisingly robust. They tend to have lower arterial stiffness, better endothelial function, and more efficient cerebral blood flow compared to elderly individuals with cognitive impairment. These features help maintain oxygen and nutrient delivery to the brain, prevent ischemic damage, and reduce the risk of stroke-related cognitive deficits. Importantly, lifestyle habits common among centenarians, such as moderate caloric intake, physical activity, and low smoking rates, support cardiovascular and cerebrovascular integrity, indirectly bolstering brain health. Interestingly, even when centenarians do show neuropathological hallmarks associated with dementia, such as amyloid plaques or tau tangles, their brains often remain functionally intact. This apparent paradox has led researchers to propose a concept of cognitive reserve, the brain's ability to compensate for structural damage by recruiting alternative neural networks or enhancing synaptic efficiency. Lifelong intellectual engagement, education, bilingualism, and rich social environments may all contribute to building this reserve, helping explain why some individuals remain mentally sharp despite underlying pathology. Centenarians also tend to preserve mitochondrial efficiency in neural tissue, which may help sustain cognitive performance. Mitochondria not only provide energy for neuronal function, but also regulate calcium signaling and apoptosis. Dysfunctional mitochondria are implicated in several neurodegenerative disorders. The brains of cognitively resilient centenarians often show reduced oxidative stress and better mitochondrial dynamics, potentially linked to favorable genetics, lifelong metabolic health, and nutrient-sensing pathways modulated by factors like sirtuins and AMP-activated protein kinase, (AMPK). Together, these findings paint a picture of the aging brain not as inevitably deteriorating, but as capable of adaptation and resistance, given the right constellation of genetic, molecular, and behavioral factors. The resilience seen in centenarians suggests that neurodegeneration is not an automatic consequence of advanced age, but rather the result of complex biological processes that, in some individuals, are slowed, compensated for, or even prevented altogether. Understanding the mechanisms behind this resilience has profound implications. It suggests that strategies aimed at increasing BDNF, reducing inflammation, preserving vascular function, and supporting mitochondrial health may not only delay cognitive decline, but also enhance quality of life in the final decades. As research on cognitive aging continues to shift from a focus on pathology to one of protection, centenarians offer a living blueprint for what successful brain aging can look like. Rather than being outliers, they may represent the potential within reach for many, if the right conditions can be fostered early and sustained throughout life.